All right. Good afternoon, everyone. Thank you for joining the Boston Society for Architecture's Embodied Carbon 101 12-part series. We are following up on the Embodied Carbon in Buildings conference that the BSA presented about a year ago. This series will bring you embodied carbon programming almost every Monday throughout the summer to provide foundational knowledge in different impact areas and to give you tools and takeaways to apply to your daily work. And before we get started, we'd like to just take a minute to acknowledge what's going on in the world around us on behalf of the BSA. We would be remiss if we did not acknowledge the nation's history of racial injustice and the fact that while we're here now, working on a Monday as usual, current events and this human rights crisis are heavy on our hearts and our minds. I hope everyone is staying safe. Personally, I know I find it overwhelming to know how I can best make a difference when surrounded by so many urgent challenges. But today, I just want to remind us all that climate change, climate action, and social equity are critically linked, and tackling carbon emissions demands collaboration and innovation across our industry. I hope that this series can leave you all with a sense of optimism about our ability to make positive change in the world. So again, this is the series schedule for a full summer of Embodied Carbon fun. And I am Lori Ferriss, Director of Sustainability and Climate Action at Goody, Clancy, a Boston architecture planning and preservation firm. I'm really excited to be here today kicking off the series and moderating our first session on basic literacy of embodied carbon. And I'm really delighted to present this, this really superstar panel of leaders in the embodied carbon world, beginning with Stephanie Carlisle, Principal at KieranTimberlake, an architecture planning and research firm in Philadelphia. Stacy Smedley, Director at SKANSKA USA in Seattle, and currently the Executive Director of Building Transparency, the nonprofit that launched EC3, and Francis Yang, Structures and Materials Sustainability Specialist at Arup, an international engineering firm. And I want to take a moment to thank our sponsors before we get started. ARC Woods and Services, Goody Clancy, Huber Engineered Woods, Select Building Products, and Thought Forms. We are very grateful for your support. And also thank you to our partner, the Associated General Contractors of Massachusetts. And I'd like to recognize that this program series is supported by the Carbon Leadership Forum and its local knowledge community, CLF Boston, which we invite you to join if you are interested in participating in our local embodied carbon discussion. And before we jump in, just a couple of housekeeping notes. This course is eligible for one health, safety, and wellness learning unit. For those who are eligible, there's a link to the Google form in the chat box, so please add your name and information there if you'd like that unit. And if you'd like a certificate but are not an AIA member, you can also enter your name in that location. We are recording this session and it will be posted to the BSA website, architects.org, later on this week. We will have a live Q&A at the end of the session, so please use the Q&A function to type in your questions as you have them. We may not get to them all today, but we will use them to inform future programming, including the upcoming 11 sessions. So with that, let's begin. So I'm just gonna spend a few minutes framing why we care about embodied carbon. So we know that in order to avoid really catastrophic impacts of climate change, we need to limit global warming to 2 degrees Celsius and ideally to 1.5 degrees Celsius. And the IPCC, the International Scientific Community, has run many scenarios to assess how this is possible. And really the only way we're going to achieve this is to be zero carbon by the year 2050. But what we know is that we're not really on track to meet that target. And because of that, the next decade is even more critical. In order to make, to really have a good chance of meeting that goal of 1.5 degrees Celsius, we need to make dramatic reductions by the year 2030. So over the next decade, we're looking at reductions of about 65%, which means that we need to really radically and immediately change the way we do business in the AEC industry. And buildings play a really large part of this, in global warming, contributing roughly 40% to global emissions. I think many of us are probably used to seeing this pie chart, understanding that building operations, heating, cooling, power, etc., account for roughly 2/3 of building-related emissions, and the other piece of that is from building materials and construction. That's the embodied carbon piece. And when we start to look at this further, we realize that the reach is even further than that. It's not just that 11%, but really buildings account for really a large part of that industry piece of the pie. So concrete, steel, and aluminum contribute over 20% of all global emissions, and that other industry wedge includes a lot of materials that go into buildings, including sheet metal, interior finishes, and the like. So I think, you know, we as professionals in the design and construction industry need to take ownership of this pie and really think about how we can start to reduce our emissions. And as I said, the next 10 years are really critical. When we look at new construction between now and the year 2030, embodied emissions will account for roughly 75% of all emissions, 2/3 or 3/4, excuse me. And so it's really important that we address the full life cycle. We need to tackle embodied carbon emissions now if we want to have a chance of meeting those climate reduction goals. We also know that we're building really rapidly. Between now and the year 2060, we're projected to double the square footage of our current building stock. And for context, that's approximately equal to adding a new New York City every month until the year 2060. So I think, you know, this fact highlights, first off, that we need to better think about how we can reuse our existing buildings and think about opportunities to build less and increase our rate of renovation. And then we also need to rethink the way we build when we do need to add square footage. And since this may be a little bit of a new concept to you to think about different types of emissions associated with buildings, I'm just going to quickly look at this graphically. So, and again, embodied emissions are the emissions associated with the building materials and construction. So at the beginning of a building's life, you have this spike in embodied emissions. That's from all the materials that are going into that building at the beginning of its life. Embodied emissions stay relatively static over the building's use, with obviously some materials going into a building. And then every time you renovate a building, you have another little spike associated with all the materials and construction activities of the renovation. Operational carbon is, I think, what we're more used to talking about, which is there are emissions associated with using the building. So at year 0, there are no emissions. And then every year you use the building, you're emitting carbon associated with energy use in the building. And hopefully every time you renew the building or renovate it, that slope goes down as your building becomes more and more efficient. But what we really need to tackle are the life cycle emissions, the total emissions. And these are what we need to get to net zero, and these are what we need to reduce over the next 10 years. And so we really need to be looking at and addressing both the operational emissions through efficiency and the embodied emissions, which is what we're here today to discuss. So I just want to reiterate that we have a huge opportunity here to transform our best practices, the way we work with our supply chain, and the way we collaborate with each other to tackle embodied emissions. And I hope that today's session and the rest of the series will give you all vocabulary and tools that you need to make an impact now. And with that, I will hand it over to Stephanie.
Oh my gosh, not that one. This one. All right, can you hear me? And can you see my slides full screen? Anyone? Stacy's nodding. Okay, so I'm gonna go ahead. So my name is Stephanie Carlisle. I am the principal and environmental researcher at KieranTimberlake. I'm really happy to be here with all of you today virtually. Thanks, Lori, for that really good introduction and a really good discussion of what the issue is around embodied carbon and why we care. So I'm gonna pick this up and talk about it a little bit from the perspective of an architect. Both define these terms in a little bit more detail, talk about how the work to radically reduce embodied carbon fits into an architect's workflow, give a few examples, and then pass it over to Francis. So embodied carbon, as we've already mentioned, are really the carbon emissions associated with materials and construction processes throughout the entire life cycle of a building or infrastructure project. So it's part of what we've started talking about as a total carbon picture, in which we can think about both the operational carbon of the building and also the embodied carbon, which is sometimes called upfront carbon, in that it's the carbon emissions and all of the environmental impacts, really, many of which happen before the building is even occupied. So a really, really critical type of emissions for us to be looking at particularly in connection to our 2030 goals and the aims to radically reduce climate change, which Lori was just speaking to. So I come back to this graph, which we've just seen one more time. It's a slightly different version. It really hopefully pushes us to think a little bit more about these total emissions connected to a building project. So the building operations, which we really, really must radically reduce as quickly as possible and move towards net zero buildings. But these other slices of the pie, so to speak, that as architects we've sort of been ignoring or really underemphasizing for a long time. And the reason I wanted to show this again is just to make the point that not just that our environmental burden or our guilt or our obligations have gotten larger and larger, but really encouraging architects to really think about the fact that we touch many, many, many sectors. And we have a lot of power and a lot of agency outside of just the performance of a single building. So I hope that an emphasis on embodied carbon really helps us think broader about what architecture is and how we can help decarbonize the building sector, but also work on industry and all of these other sectors as well. So there's a fierce urgency for us to be talking about embodied carbon. There's a fierce urgency for us to be tackling it as soon as possible. And for that reason, we really need to be thinking about how we address embodied carbon, not just on the special projects, not on the one-off projects, not on our timber projects, alone, but really how to think about how we spread this practice of life cycle assessment and thinking about carbon across our entire portfolios and our entire industry, right? And so I really want to put out there this charge that we're all faced with right now of radically decarbonizing our entire industry and the real amount of fierce collaboration that that's going to require if we take that charge seriously. And so that really means, and part of why it's so delightful to have architects, engineers, contractors all on the same call together, all in the same presentations together, is that I think all of us feel this shared mission in which across the whole building industry, we all have a role to play. And we really need to think about how we can collaborate. So if we are aligned on this idea that we must tackle embodied carbon, how do we actually do that? So the way that we actually assess and model is through a practice called life cycle assessment. Life cycle assessment is simply the evaluation of all the inputs and outputs and the potential environmental impacts of a product system through its entire life cycle. Practice is new to the architecture profession and to our industry, but it's been around for almost 40 years, used from product design to manufacturing, et cetera, and is a really robust framework to help look at complex systems. So it's going to help us understand all those inputs and outputs, starting with resource, all the way to resource extraction, land management, all the way through manufacturing, construction, use, demolition, or end of life. Sometimes this is a helpful diagram to think about all those, what we call life cycle stages. And when we're running LCA models on projects, no matter what software we're using, those tools are really helping us think about all those material, energetic inputs going into those systems, and then all of the different emissions and outputs. So whether we're running what's called a cradle to gate LCA, which is just going to look at that initial manufacturing or construction, or a full cradle to grave LCA, which is going to look at the entire product system, all the way to end of life, recycling, reclamation. So these are all terms as architects we might not be totally in the weeds on with modeling, but we're all going to have to start getting a little bit more used to. Behind all those models is, and what is actually going on in the analysis, is this incredible management of chemicals, materials, and manufacturing. So this is just a really quick snapshot of a comparison of two different really, really, really simple products. So a foam insulation product, as well as a spray foam insulation product. And so behind all these simple data sets are lots and lots of processes and all the manufacturing, as well as all the outputs and global warming potential associated with things like blowing agents, construction activities, et cetera. And as we scale up and move from a single material to assemblies, one can imagine that that accounting becomes more and more complicated. Luckily, you're often not really going to be getting all the way into the details of all of these different assemblies, but making use of good LCA tools that help manage that complexity. Because once we really look at whole buildings, there's really two sides of this equation. One is figuring out all the materials that are coming together. So we often call that, this is a bill of materials of a very pretty small residential project, as well as all of the manufacturing end of life side. So what LCA models are really doing is taking all of that background data, the LCIA or inventory data, and then translating it into environmental impacts. So mostly on this call, we're talking about embodied carbon or global warming potential. The life cycle assessment also covers a whole range of other impact categories. I just want to mention, we won't go into this in any detail, but there are a huge range of tools that can be used to do LCA and are really going to make this connection. So as a practitioner, you're probably mostly living in this world of the third column. So if you're running whole building analysis, you're probably using Tally or OneClick or Athena, but there's also lots and lots and lots of other new tools and plugins that are coming online from EC3, which helps you look at single materials and assemblies, through to Beacon, concrete calculators, and all sorts of other tools that are helping to streamline this process. Those tools are all going to draw on underlying software as well as underlying databases that are going to pull together all of that background data that I was just showing in those diagrams about how materials are made and help us make comparisons. So really what LCA is asking us to do as designers and practitioners is hold in place two really different types of complexity. On one side, really come to terms a lot more with how things are actually made and what the impacts are far beyond the building site. And on the second side, what's really, really complicated about LCA is actually grappling with buildings as systems, right? Where materials are coming in and flowing out. It's not really this single point in time. And modeling a building is actually a lot more complicated than a plastic cup or a cell phone or some of the other simple products that have long been modeled in life cycle assessment. So there are three main challenges that LCA really asks us to grapple with. The first one is resolution. So the tools are going to help you translate between what we often are doing as architects, which is expressing design intent, thinking about a wall type, for example, here. This is how it's often graphically shown in construction documentation or in your BIM model, and really translating that to the actual material quantities, which we need to run a proper LCA model. The second thing it's doing, if you're running whole building LCA across all those stages, is thinking about time. So how materials come in and out and balancing those trade-offs around topics like durability or maintenance. So what are that initial push during construction, and then what are these other replacement and maintenance impacts as well as end of life? And then the third big concept that I think LCA asks us to grapple with that we're really, really just trying to scratch the surface on is thinking about this question of scale and scope. So this is an example, it's a diagram by Gray Ordansky Architects from a project called Timber City, really thinking about how we are looking at engineered wood. Not only are we trying to grapple with the construction detail, the manufacturing sequence, the cost, the buildability, but really LCA is asking us to look all the way back to how that timber was produced, how that land was managed, and ask a whole new range of questions that I think are really exciting for designers to grapple with. So now I'll just go really quickly through some of the basic types of LCA. I'm not going to go into any detail on these case studies. I think the next segments in the carbon sequence, all the next webinars are going to get into lots of detailed case studies, but I just want to give everyone a sense, if this practice is new to you, what this really looks like across an architectural project. So I like to break it down in our practice about 3 or 4 specific kinds of LCAs that you might run across the course of a single project. So the first are, you may be interacting with EPDs, and those are environmental product declarations. Those are like mini LCAs that someone has already run about often a single material. They're very, very helpful, and hopefully you can start getting more familiar with how these are published and what the data looks like. Tools coming online like EC3, which I think Stacy's going to talk about in more depth. They're helping designers find that data, get it together and compare it, and think about what an industry average number means and how to make improvements. So you can start working with that data as sort of like getting your feet into the water of LCA and thinking about simple product comparisons. Of course, when you're just looking at this last example, which is just different types of gypsum wallboard, comparing two products may seem really simple, but in many, many cases, the real challenge of LCA as a comparative practice is trying to figure out how to compare functionally similar things, right? And I think that's always a challenge for designers. So in LCA, we have this concept of the functional unit, which is really about figuring out how to compare different assemblies, different entire buildings even. And LCA gives a lot of guidance about how to set up functional equivalency. So we're really making comparisons that are meaningful to us. So just by way of example, this is another one that seems very, very simple at first. This is just a comparison of different flooring assemblies, just to make the point that rarely in architectural practice are we really picking materials. We're often really looking at whole assemblies. So this is just one example where EPDs, it wasn't really possible to use EPDs. The designers here had to figure out and make sure that all the flooring options were equivalent in terms of their acoustic performance, in terms of their durability, thinking about the full assembly and not just the top layer of that assembly, for example. And that gets even more complex as one starts to think about, in this example, looking at stud walls and the trade-offs between wood framing or metal framing, for example. So I think there's going to be a lot of tools, as well as I know a lot of firms are starting to do this work internally, so that you have a little bit of guidance as a designer rather than just working off of every single bespoke moment in a building project. Then when we move on to whole building LCA, I'll go through these pretty quickly, but just giving a sense of what some of the tool output might look like if you haven't run an LCA before. We like to run these very early in a project, and really you're starting to get a sense of the part to whole. Where do I spend my time? How do I focus my energy? This is a pretty typical example of a whole building LCA, where a lot of the environmental impacts here, the global warming potential, is often really tied up in structural materials. In this particular case, a great deal of the carbon footprint of the building was in concrete. So we might run a more detailed assessment. Here it allows us to identify specific materials, not just divisions, getting into Revit categories, et cetera, to really pinpoint where can I optimize, where do I need to look at, take a second look. So I can really know that I'm spending my energy on design questions that are actually meaningful. Then often we'll run these really simple comparisons. So this is probably one of the most basic examples, but just looking at concrete mixes, things like relaxing cure time, for example, and trying to understand what the actual carbon benefits are across the whole project. So this project in particular had a lot of concrete. This is not always going to be the case, but this is one where a really simple specification change made a huge difference in the embodied carbon of the project up front. And then often what we're doing is moving away from that whole building model and really running design optioning. I find this to be super useful, and it's where you can really test out design decisions that could be made for a range of reasons, whether it's price, whether it's buildability, whether it's aesthetics, durability, et cetera. So one of the real promises of LCA tools is that they can get this information on embodied carbon or environmental impact right in the hands of designers when you're making these other decisions. So it's not a separate analysis, but really something that we could just be using as part of the complex decision-making that designers are making on every project. So this example is looking right at the ground floor of this building and testing out different assemblies natively within the Revit model, looking between a cast-in-place concrete option versus a brick layup system. So really, really helpful. In our office, we like to run these analyses at the same time that we're doing cost assessments, looking at energy performance, and often even making full-scale mock-ups. So really seeing embodied carbon as part of a holistic design strategy, not a separate exercise done on the side or after the fact. And then finally, it's a lot of work is going on right now when we zoom out from the single project, just trying to understand what it even means to design a low carbon building. So there's a lot of effort, maybe we'll have a chance to talk about this more later on, getting into this question of benchmarking and understanding as firms start to look across their whole portfolios, and also as an industry, as we start to bring our data together through organizations like the Carbon Leadership Forum the AIA's new DDX database, which is going to be incorporating embodied carbon, or other initiatives like the one from Structural Engineers 2050 initiative, both of which are in process right now and should really help firms be able to understand how they're doing and help aggregate data across building assemblies and types. I'm going to skip ahead and just end on this last 2 slides, making the point that really what we want to be doing is making as dramatic gains in embodied carbon as we possibly can across all of our projects. And I think a lot of us that have jumped into the embodied carbon game are really in this space still of developing tools, of developing vocabulary, of finding out what the big win is. And I think we need to be doing that. We need to really do the same work that we're doing on operational carbon and understand what a pathway really looks like to net zero for embodied carbon, but also what are the strategies that we can be using on all of our projects. And how can we really incorporate that into our design making and really consider it part of what a high performance building or even a confident building actually is. So I just want to leave with these last kind of proposals for all of you, something that maybe you can incorporate into a project you're working on now or to any project. I think it's really important that teams start to set targets on their projects, that we're not going to make any progress unless we actually have goals, not just to do LCAs, but hopefully setting some internal performance goals themselves. Don't stop with the model. It's not meaningful if we only make carbon gains in our Revit models. We have to actually get it into construction. Stacy's going to speak to this. It's hugely important. We start really going across the product chain and really working with all of our partners to make sure that these strategies are actually built and don't get cut from the project. We need to think about how we talk to clients, but also maybe we just need to do this work, right? And I think that's a huge topic that I think will come up in other issues in this series. Bring together carbon figures and analysis with design questions. I think that's really been, I've heard, key to success across lots and lots of practices is getting embodied carbon conversations right into design reviews, making it feel relevant to everyone on the team. 5, I would really encourage folks to not isolate embodied carbon and energy performance, but start thinking about a total carbon picture. It's the only way we're going to find strategies that are meaningful on all of our projects because the trade-offs are there, right? And so I think that's a really, really important topic. And finally, we all need to advocate for this topic, but we also need to share data. We need to share strategies that are working and really all help each other across firms and practices. So with that, I will turn it over to Francis. I don't do that. Stop share.
Yes.
Does that work, Francis?
I think so. Here. Okay, and then I'm going to present. Okay, you can see my screen all right?
Yeah, it looks great.
Okay, so as introduced, I'm a structural engineer, so we're going to talk a little bit more about structure. And this is because as a portion of that upfront embodied carbon, structure is often more than half for buildings made of concrete and steel. So even when we're considering different types, like shown here, the combination of superstructure and substructure is often more than 50%. So what do we do about this? Well, lifecycle assessments can actually help us answer this question. And here are some of the top 5 strategies that I think LCA have taught us over the years. And at the same time, I hope to use these examples to illustrate more about a lot of the LCA fundamentals and build upon what Stephanie's now introduced already. And this is to really help you understand the some LCA principles that are important to keep in mind when doing LCAs. Right, so the number 1 strategy, as you've heard already, reduce and reuse, right? This is including reuse of existing buildings. It's also reducing the size of what we need to build new. And then when we can't do that, then at least trying to salvage or use salvage building components. And the reason for this is because the manufacturing of materials like cement and steel are so energy intensive. There's also carbon dioxide that's released in the chemical reaction that occurs in making cement and also in virgin steel. And so the production phase of the life cycle impacts is usually what dominates these materials. And then once you see this, it's obvious why the more we can avoid those processes, those manufacturing processes, the more we can cut out the carbon emissions that occur in using these materials. And then the second strategy of material efficiency comes from the simple equation that Stephanie also introduced. Embodied carbon is really basically material quantities times embodied carbon coefficients. So while we talk a lot about what contributes to the embodied carbon coefficients, everything over the life cycle of the materials, equally part of this equation is the material quantities. And so I like to think that material quantities are to embodied carbon the way energy use intensity has been to operational carbon. So in essence, material efficiency is the new energy efficiency. Okay, so what's great about this strategy is that structural engineers already strive to form material efficiency all the time. It's just part of their job. And computational optimization has helped us get better and better at it as well. So on the new international airport from Mexico City, these kinds of advancements, they helped us reduce the weight of the roof down further than we had in any of our past airport projects. But equally critical was actually what you don't see is a close collaboration with Foster's and Free, and an approach to design that allowed the geometry of the structure to follow the optimization. We don't need fancy algorithms necessarily to make structures more efficient. There are actually a lot of other systems and ideas that I think are just underutilized. We don't use them enough, really. And it's often because of cost or unfamiliarity, other challenges at the moment. But I think we're going to need to really turn to those techniques more and quickly if we're going to have any hope of driving down embodied carbon as soon as we need to. So the third strategy would be reducing cement. You've seen, yes, again, Stephanie showed that example where the impacts from concrete were really enormous. This occurs where steel structures, timber structures, and it's because in steel systems, we still use concrete in the floors. And for all structures, you're nearly always using concrete in the foundation. So just as we don't normally need as much material as we put in our structures, we don't need as much cement as we're commonly putting in concrete. On here, the SFO airport, we were able to use the environmental product declarations, as you see from Central here. These are EPDs, and we could carefully tailor the concrete mixes, and actually limit the GWP based on looking at a lot of EPDs and really just talking with suppliers early, talking with contractors early, and actually end up with significant reductions in the embodied carbon. And now this also brings up another tenet of life cycle assessment called sensitivity analysis. So we want to keep in mind that there can be significant variability that isn't always illustrated by the LCA tools that use a single embodied carbon factor when there can actually be a range for that material, right? So for instance, here we were comparing a variety of concrete and structural floor systems. And while you might see that there is a particular system that might appear to have the highest embodied carbon overall, if we specify the concrete to be very low impact, it could end up lower than if we chose a system that appeared to be lowest, but we didn't do anything and paid no attention to the specification of concrete, and it could end up being higher than the one that initially appeared to be highest. I hope that makes sense. So in any case, being aware of the sensitivity of the results to other factors and then testing them can help us see more clearly which of our design decisions are most critical. Okay, number 4 was, I alluded to timber, but it's really about using carbon storing materials instead of the highly carbon emitting materials. In this case, it would be using a timber structure instead of a concrete structure. Now the graph on the right, it illustrates carbon emissions over time, comparing a concrete flat slab system to a mass timber system, and it's highly simplified abstraction. The main point is that the benefit of the timber option, of course, comes from that sequestration of carbon dioxide during the growth of the trees that make the structural wood products. And it also shows, you can see just a little bit, the difference in avoiding the more energy intensive processes required in making rebar and concrete. And now making comparisons with wood gets complicated really fast. So there are 3 more LCA fundamentals I'd like to remind us about. The first is that we should make sure to understand which life cycle phases are included. You might wonder why sometimes with wood you see carbon positive factors and sometimes, or positive carbon factors and sometimes negative. And it's often because there are different methods for deriving those carbon factors. They don't start and stop at the same place over the life cycle. And here you see 7 different methodologies that are not aligned. So in the end, they land on different carbon factors for wood. The second important fundamental is functional equivalence. And Stephanie mentioned this as well. Right, here's an example now where it's really important to keep in mind that we have to do apples to apples comparisons. Sometimes we see studies that only show the structural portion of a timber system compared to concrete, but that would leave out all of the materials that are often needed to make the wood system provide all of the function that a concrete system would offer inherently. So for fair comparison, we should ensure that the functional equivalence in the wood system, we need to add in the materials that provide especially the same fire and vibration performance as the concrete system. So it's important to include those extra materials in comparison. And then lastly with wood, it's really important to remember that with an LCA, we're looking at a limited system boundary. Either with EPDs that are usually cradle to gate, or even with LCA tools that expand that a little more. There aren't currently LCA tools that account for how our procurement choices could influence what happens in the forest. And there's the carbon in the forest is magnitudes larger than what's sequestered or stored or coming out of the processes in making wood products. So we have to realize that we might need to turn to other tools too, or we should turn to other tools too. That forest certifications and carbon offset programs, those are some examples, are needed to fully inform our decisions around wood, because LCAs don't always tell us everything, even around carbon. And then the last of the 5 is design for deconstruction. So thinking ahead about how we could change, this term cradle to grave that's used in LCA, how could we change that to cradle to cradle? So how could we build now so that in the future we can use those materials for new buildings? And it's basically going back to strategy number 1 of using reuse or salvage. Okay, so now I want to talk a little bit about baselines versus benchmarks. These are commonly used to quantify how are we doing? Like, are we doing better and by how much? Now with baselines, and I think will be covered a bit in the certifications and rating systems course later, but they're usually in those programs because we need to demonstrate some kind of savings when comparing your building to some kind of baseline. But the baseline is often a fictitious design that is a better representation of business as usual, or what would result if there were no interventions. So there are a few standards and guides out there to help us define this baseline, but in truth, we don't quite have the equivalent of an ASHRAE 90.1 Appendix G that we have for operational energy baselines. And so that's something we're gonna need to work on as an industry towards a better standard for what is to defining the baseline for these comparisons. And now benchmarks, I think of as a little different. This is where we're looking to see how our design compares to other real projects that are similar. And they're often used for setting targets, right? And for policy even. Now the Carbon Leadership Forum did a benchmarking study in 2015, and it's probably the one of the best sources for benchmarks right now. But if you look more closely at the data, you'll see that there's actually a lot of big gaps in the information that was available. And if you look even closer, there was a lot of inconsistency in what building components were included and the source of the embodied carbon factors used from different data sets. So basically, we need more data from projects, and also in a way that's collected in a way that's more consistent and gives us the granularity we need to set better benchmarks and targets especially as on our way to getting to zero. And what's exciting to me is that this is one of the undertakings under SC 2050. Last September, the Carbon Leadership Forum issued a challenge called SC 2050 Challenge, and we're now working on a commitment program that's modeled after quite a lot by the AIA 2030. And one of the primary aims is to engage structural engineers to report embodied carbon of their designs to a common database so that we can get to those benchmarks and establish the targets more quickly, as to get everyone on the same road and the same path to zero. So it's meant to also be a resource to inspire and equip structural engineers. And if you know any structural engineers or you are structural engineers, then I'd encourage you to check out our website at sc2050.org and join us. And then, even if you're not a structural engineer, I hope that you'll keep these 5 strategies in mind and remember these LCA fundamentals, because I think they're really important to get the most out of LCA and do the most in reducing embodied carbon. So now I'll turn it over to Stacy, who will talk about embodied carbon in construction.
Thank you, Frances. I'm going to try to share my screen. I'm going to try to go a little bit faster. I talk fast anyway, so we should be fine, just so that we have a few minutes at the end for questions. I know we're at 12:45, so I won't skip anything, but I might go a little quicker than I was intending to, just so we have some time. So my name's Stacy. I am a sustainability director at SKANSKA USA, which is a large global contractor. And I'm also the current executive director of Building Transparency, which is a new nonprofit that is focused on providing tools such as EC3 that are open access to help actively reduce embodied carbon today. What I'm here to talk about today is really how contractors in the construction industry can look at embodied carbon and why we think that we have a role in really addressing this as an industry. This is a slide I typically use when talking to contractors because what it's really showing is when we're talking about operational versus embodied carbon. Operational carbon, we all know, is what happens once we've turned over those buildings to their owners and the lights turn on and the systems start to work and the energy starts to get consumed. And embodied carbon is really everything before that. It's all these things that contractors are actively engaged with, whether it's how we extract and procure materials, how we transfer them to our construction sites, and how we install them. So it's really a tangible thing when you're thinking about this from a contractor perspective, because it is the stuff that we work with. It's the building materials. So I believe that contractors have a very large role to play in this, and we need to approach it as an industry in terms of how we address this. So you've seen a version of this slide, I think, in Stephanie's presentation, but it's also from the World Green Building Council's report. And this is just to kind of ground everyone in the stages again, because this really impacts where contractors can play in this embodied carbon world. So just going through the stages with my little cartoon graphics, there's, again, the product stage and the construction process stage, which is upfront carbon, largely when people are talking about that upfront embodied carbon component, and it's stage A. You move on to stage B, which is the use stage, how we look at replacement of materials like carpet or roofing systems over the life cycle of the building. So really very dependent on owners' kind of requirements around that and how one might want to change out something if it looks old on a project. And then end of life, which is really how we deconstruct buildings, like Frances was mentioning, how we reuse those materials and where they go through the waste processing and disposal process. So again, that's really embodied carbon in the stages. Looking at it from a construction perspective, it's really that stage A and stage C where we as contractors have the most impact. And within those stages, these are just some plus or minuses because this can change based on what reports, but based on data that we've developed at SKANSKA and on our projects, you can see here that that stage A is a large portion of the overall embodied carbon footprint. And then the end of life stage also has a component to play. And then within stage A, you're looking at the product stage, which is really that manufacturing stage versus the construction process stage. The large, again, I think you've heard this before, but that manufacturing stage is where the most emissions kind of play out. And so if we're going to start somewhere, really looking at how we are procuring products and where from, and are they the lowest carbon options, is how we've approached this so far. One thing that we also tend to think about from a SKANSKA perspective, but just for construction in general, is really moving that end of life stage up front. When we are building a building, typically we are demolishing a building first, or we are clearing a site. And so we really need to think about how we are taking those materials down, how we are recycling them into new products when possible, how we are not just looking at waste diversion from a percentage reduction, but also from a carbon perspective. So again, thinking about that on the project that you're deconstructing now, in addition to the project that might be deconstructed in 50 years. So at the end of life stage to start, there are just some typical things that are good lessons learned and really kind of rails to guide you. So of course, setting project goals around construction waste during pre-construction, quantifying those opportunities for deconstruction before you're putting together your bid documents, working with companies that would come in and actually tell you what it would take to take out the gypsum board or deconstruct the structure of a building. And then getting into construction, it's really looking at the bid documents to make sure you're addressing project waste. They're also tracking it actionably and also looking at not just percentage reductions again, but the carbon emissions associated. So here's just an example of a report that SKANSKA puts together for waste, where it's not just looking at it from again, tons reduced, but also from gallons of water consumed for things like demolition or carbon emissions. So again, building carbon into how we actually track and report these things, even at the end of life stage when we're demolishing buildings. The next is really that key stage in our minds, that A1 to A3 stage, where we're looking at that large crux of embodied carbon of what we're procuring and putting into place. And again, there are just lessons learned about making sure that we're looking at carbon and cost in pre-construction, that we're looking at project specs from our design teams, seeing if it's addressing environmental product declarations and goals, and then actually starting to engage our suppliers during pre-construction. If we know that carbon is something that we're going to track on a project, if we're building that into our procurement documents, getting ahead of that with suppliers, letting them know it's coming, that they should invest in EPDs, then they should also know that it's going to be part of the bidding criteria. During construction, again, it's building it into the bid documents, so we're addressing embodied carbon and EPD requirements in bid language. We're putting it into our leveling sheets, so we're looking at EPD generation and carbon quantities next to cost when we're looking at our bids. And then tracking the materials that we procure and actually assuring, I think that was just mentioned at the beginning, that we are achieving the savings that we've set for ourselves during whole building LCA and our specifications during design. And so when we started looking at this for the construction industry, looking at the LCA tools out there that were doing a lot of that early work about right-sizing your building and looking at systems versus each other just to reduce embodied carbon, what we couldn't find was that next stage where, as a contractor, we would want to have language and specs that said, okay, you're using carpet, let's make sure that we are specifying a carpet that has an EPD and that also has a certain kilogram of CO2 value as a basis of design. So then we can actually bid on those documents and actually procure and track the data. And really both of these things need to happen, this early LCA assessment plus this specification and procurement assessment, to really reduce embodied carbon, have it be realized. So EC3 has been the tool that's been developed, starting at incubation at the Carbon Leadership Forum and now housed at buildingtransparency.org. That's a free open source tool that's trying to be a resource for the industry when it comes to being able to access EPDs, understand who has them, who doesn't, and start to set baselines, benchmarks, and reductions depending on how you search and sort the data. And so I just encourage everyone to go register and log in and get your free access. There's no cost to join to be able to do the next things I'm going to show you. You saw a version of this with Francis's presentation too, but really this embodied carbon accounting is similar to cost estimating. So we call what we do on the construction side an embodied carbon estimate, where we can take kilograms of CO2 as our units multiplied by material quantities that contractors generally have for estimates and get to an embodied carbon estimate for the project alongside a cost estimate. And again, EPDs are the source of that data where you can get to that unit per product. And that's really the step once you've made those whole building LCA assessments, where you want to actually look at the products you're procuring to get that actual realized savings. And we just use this nutrition label comparison to say it's got a serving size, which is the declared unit, and a carbohydrate, which is the kilograms of CO2. Those are really the data points that we need to do these assessments at the product level. So EC3 has a database of over 22,000 EPDs. It starts with certain categories. What it allows you to do is actually see digital versions of these EPDs and begin to do things like search based on what you know. If you know you have a project in California that has a 5,000 PSI concrete mix and it's going to meet by Clean California, you can start to search the system for things that are compliant. It will produce a sampling of all the EPDs that match your search. And then you can start to dig into the data and do the multiplications to get a project level estimate of that supply chain data. So this is just looking at potential reductions versus material types. Here's the scales of impacts using that EPD data and material quantities. And the white area is this available reduction based on current supply chain data of EPDs. So when you're thinking about procurement choices, if you know you have rebar, the location of that plant where you're procuring your rebar might give you a huge savings because they've got a better energy grid versus another rebar plant. So it's giving you data to start to see where savings actually exists. This is kind of low-hanging fruit in our minds, where it's just really being smart about how you specify based on carbon. The other thing that it can do is really start to help set these baselines and benchmarks and limits, and the words that Francis has said very rightly so, we're still trying to figure out. But if you have data from your suppliers, this is looking at Cal Portland, Stoneway, and Cadman concrete suppliers in Seattle. Cadman only has one EPD in the system at that time, but you can start to directionally see what suppliers are being more efficient in their mix generation in general, but also if you draw lines across, where could you set a limit or a benchmark or a target based on the data in the tool. And then what SKANSKA started to do, and we actually now on the building transparency site have resources available on the resources tab where you can download some of this language that's been templated. But you can actually build this language into your specifications and bid documents. This is an example of a bid template where we are talking about requirements for EPDs, that we are going to look at targets and reductions, and then questions like, if you don't have EPDs, will you get them? If not, why not? And if so, will you burden the project with the cost? So really questions to really drive the market, and we need these things in specs and procurement language to actually start to have the market signal be sent to manufacturers to disclose, declare, and then reduce. And the last thing is at end of the day, where you want to actually see your realized savings is if you actually select EPDs. Contractors are used to tracking submittals for things like just EPD credits and lead or recycled content in the older version. So it's just another thing that we can actually track, get all the EPDs into a database and actually see the realized savings for a project and know that we actually did actually achieve that savings. I'm going to just talk briefly about the fact that we do track the construction stage. This is that 5%, and there's a lot of work, and there's not really a standard for this in the construction industry right now. Here's an example of how SKANSKA has set up a template to do this, where we look at all the different things. It's a whole bunch of data, and this is like, I think, the Wild West of embodied carbon. If where we are now is better than where we were 2 years ago, this is still an aspect of it that is very kind of in a template understanding stage, but we need to do better on this, and we're starting to figure out ways to track that actionably on our job sites. With that, I'd like to stop. I think I left us 4 minutes.
All right, thanks, Stacy. So I think we have a few minutes for questions, just a couple of minutes. Let's start off with one about the ratio of operational to embodied carbon. So going back to the global emissions pie chart, it's about 28% operational and 11% embodied. And the question is, what does that ratio look like at an individual building level? Obviously, this varies due to many factors, building by building. I don't know, Steph, do you want to, based on your many LCA studies, answer what how this manifests in a single building?
Sure. Well, I will answer as usual by saying it depends, and it's complicated, which is a bad answer. But so the two things that are really interesting, just to toss out a new concept, is that, or underscore this again, is that it also really, when we're looking at those ratios, they obviously change quite a lot depending on the amount of time we're interested in. So if you look at the percentage allocated to embodied carbon for a really poorly performing building and look over 100 years, it's going to look like embodied carbon is tiny and fractional. If you're doing a net zero building, embodied carbon is all of it, right? So you got a lot of work to do, right? But I think I would also really encourage people to think about this topic of the time sequence of carbon and really thinking about the carbon emissions that happen in that critical next 15, 20 years, some would even say 10 years, that are really, really, really important. And when we look at the percentage attributed to embodied carbon over the first 10 or 15 years of a building life, it's most of it, right? So that can be really challenging. In our office, we tend to run those numbers for 2030 as for 2030 tracking. So what is the percentage up to and before 2030? Because it's really, I find that to be particularly helpful in understanding it. So, but the range is going to be all over the place depending on what the EUI of your building is and the building type.
Can I just add one thing to that? Because we've done this study for a project. I was trying to find the slide real quick, but I think what's really interesting is if you take the same project with the square footage and an EUI, and then you put it in 6 different places in the States, that swing is, it can be, 40-50% change based on the energy grid. So it's, again, there are layers. And I think that just wrapping your head around it and starting to do some of these studies using the benchmarks out of the CLF benchmarking study and your local grid and EUIs that you set. But yeah, I mean, the average is that 50-50-ish range, but you can swing from 80-20 to 90-10 or 10-90, depending on where you are and what your grid looks like.
Yeah.
Okay. All right, maybe one more. I've lost my chat screen, so I don't know, Caitlin, if you're telling me to stop, I can't see. How about, what is use stage embodied carbon? It sounds like an oxymoron to those of us less familiar with LCA.
Well, that one's easy. The simple answer is that use stage embodied carbon is replacement, right? And so we tend to focus a lot on structural materials that last, hopefully, for the life of the whole building, unless something has gone horribly awry. But lots of materials don't and cycle in and out. So that's everything from repainting the walls, swapping out gypsum finishes, hardware, fasteners, all of the materials that kind of cycle throughout the whole building during repair and replacement would fall under use stage.
Okay, I think I'm gonna stop us there. Some other good questions that we'll certainly answer in the next few sessions. Another thank you to our panelists. That was a really excellent introduction. I think really motivational and informative to get everyone thinking about embodied carbon across all aspects of the industry. Thanks to all of our sponsors again and our partner. And I'll just remind everyone that next week we'll be talking about environmental product declarations. So join us again for that session, and thank you all.